So what I want to talk in this lesson is I want to talk about how are all of these other heavier elements formed and what is the process for those being formed. So we've kind of talked about how all of the other elements right up to iron is formed. So up as far as here, up to 26 elements. What I want to talk about now is like how do all of these other heavier elements get formed and what is that process? So in order to understand the formation of the heavier elements, so the formation of heavy elements, so remember when we talk about heavy elements, we're talking about the elements up after iron. So let's say from cobalt on. So let's say elements that are greater than iron, Fe and above. So how are they formed? So we have this process and it's called the neutron capture process. So it's neutron capture process. So this is a process that happens and it accounts for the formation of, let's say, these heavier elements from iron on up. So how does this process work? So what we do is we start off with a seed. We start off with a seed nucleus. So we have, let's say, so this is our seed nucleus. And this could be, for example, it could be iron. So iron, for example. So this is our seed nucleus. And then what happens is we get these neutrons. So remember these subatomic particles, so neutrons. So these are neutrons. And we get this thing that's known as a neutron flux. And what happens is these neutrons, they bombard the seed nucleus. So these neutrons bombard the seed nucleus. And what happens is you get this big, let's say it's an iron nucleus that's been seeded with loads of these neutrons. And what happens is this huge newly formed nucleus, this much bigger nucleus, is formed, and this is actually, it's unstable. It's unstable, and as a result, it's radioactive. So that means that it wants to go back into a stabler form. So you can imagine you have this iron seed nucleus, and it gets seeded with all of these neutrons. So this is where you get this neutron capture. So if you like the seed nucleus, it captures all of these neutrons inside a neutron flux. So it's a space where you get all these neutrons being formed, and it picks them all up. And as a result of that, it becomes this like big unstable ball of a nucleus that is unstable and it's radioactive. So radioactive means that it will just spontaneously break down. So we have some radioactive substances like uranium already at the moment, but what happens is they start to break down. So this breaks down by a process that's called beta decay. It's just abbreviated like this, beta decay. So beta decay. Another way to kind of think about this element as well, it's neutron rich. And it's also an isotope. Okay, so it's neutron rich, so it just means that it's been enriched, if you like, with all of these neutrons. It's full of neutrons. So what this does is it's unstable and it spontaneously undergoes this radioactive decay that's known as beta decay. So what happens in beta decay then is that, so imagine in here you get neutrons are converted into protons. And then what also happens then as well is you get this high energy electron. emitted. So you get this high energy electron emitted. So essentially what you're getting is you're getting these neutrons. So the iron nucleus gets seeded with all of these neutrons. It grows into this big unstable nucleus, and then it undergoes beta decay. So in beta decay, what starts to happen is you get neutrons are converted into protons. So if you remember, it's the number of protons that an element has that indicates the type of element that it is. So for example, if we look here at iron has 26 protons. So if iron nucleus gains a load of nuclei, a load of neutrons, what happens is the mass number increases and it becomes what's known as an isotope, but it's still iron. So essentially, like this here is like it's still iron, because it only has, let's say, the original 26 protons that it starts off with. But over time, what starts to happen is protons start to get converted into, or neutrons start to get converted into protons. So the atomic number, or the number of protons in the nucleus, increases. So as a result of that, as we get these new protons being created, we get new elements. We get these newer, heavier elements being created. So that's essentially what's happening there. And what will happen is this process will happen. So you're going to get neutrons being converted into protons. And this will happen over a long period of time. And eventually then what's going to happen is you're going to have this stable element. And this stable element will have, let's say, a particular amount of protons within it. And that particular number of protons that it has will indicate the type of element that it has. But these elements that are formed through this process are going to be elements that are heavier than iron. You start off with iron, but you start to get these heavier elements that are formed. And like this, so for example, like this here, it just depends on how many neutrons this iron seed nuclei picks up at the start, and that it will indicate, let's say, like the type of element that it will end up being. So this is, let's say, so this process is what's known as the neutron capture process. And this goes on, and what happens is you get these stable elements formed, these stable, heavier elements, heavier than iron. So within this neutron capture process, so you have what's known as you can have like a process that's known as the S process. And this is what's known as its slow neutron capture. So it's a slower process. It happens over a longer period of time. And this slow process, it generally happens in evolved red giants. So let's say, so you get your red giant formed, and this slow process happens within it. So what's happening is in evolved red giants, you have a process, a nuclear process that's happening, let's say, within the red giant, and it's creating this neutron flux, or it's creating an abundance of these neutrons. And also as well, what's happening is within the red giant as well, you have the iron atoms or nuclei being formed as well. And what happens is they seed the neutrons that are being formed through the separate nuclear process seeds the iron nuclei, and then you start to get these heavier elements formed. And generally, this slow process, it takes on average about 10,000 years. So this process goes on over a 10,000 years, and you generally get the elements, the heavy elements, all the way up to lead, which is Pb. So through this process, you're getting the elements, let's say, so you start with iron, and you get all of these elements here, all the way up as far as lead, for example. So it happens through this slow neutron capture process. And then if we have a slow process, then you also have what's known as the rapid neutron capture process. So then you have rapid neutron capture process. So it's called the OR process. And this can be very, very quick. It can happen within 1 to 2 seconds. And generally what happens is, so when you have a supernova, so for example, when the core of the star is iron, you get this supernova process that happens. And you get this, so you get this massive flux of neutrons, and they seed iron, and then what happens is you can get these even heavier elements being formed, let's say heavier than lead, for example. So that's, and also as well, this process can happen as well. You can get what's known as a neutron star, or a proto neutron star. So for example, when the supernova event happens, you can get this proto neutron star. And then what can happen is these neutron stars can come together, and this process is very, very rapid. And what can happen is you can get a lot of this seeding process happening, and you can get very, much heavier elements formed then as well. So that is the process, let's say, on how, heavier elements than iron, the process that they're formed through, which is known as the neutron capture process. So hopefully that makes sense, and thank you for listening.